And now in this lecture we'll answer on two questions. In the first question, we find out the length of this standard MF is equal to x. And in the second question, we find out the length of this standard AP that is also equal to x. So we start with the first question. In the drawing, we have three identical circles. And we also have the big tangent ABC. It is tangent to this circle at point A, it is tangent to this middle circle at point B, and it is tangent to this circle at point C. We also know that AB equals to 4 units in length. This is 97 BC, this is also equals to 4 units in length. In addition, we have, this is the common extent point M. For this common extent point M, we have tangent MD, that is tangent to this circle at point D. The length of this tangent MD is 5 units. And we also have tangent ME, that is tangent to this middle circle at this point E. And the length of this tangent ME is 7 units. And finally, we have also tangent MF, that is tangent to this circle at point F. And the length of this tangent MF is x. And our mission is to find out the length of tangent MF is equal to x. We have to find out the value of x. So first of all, we define the center of this circle. This point is point P. We also define the center of this middle circle. This point is point Q. And we define the center of this circle. This point is point S. We join points P and D together by a straight line. Point P is the middle of this circle, point D is the point of the circle itself, therefore PD is the radius of this circle. We define the radius of this circle as R. And because of the fact that those three circles are identical, they must have also the same ODI. So the radius of those two circles must be also equal to R. And because of the fact that the radius PD is equal to R, the radius PD is going to point D, that is the point of tendency of tangent MD with this circle, and whenever your radius is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and P together by a straight line. By joining points M and P, we created the right triangle, triangle MPD. So, we implement the Pythagoras theorem on this right triangle, triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in this right triangle MPD is MP, therefore the square of the hypotenuse is MP square, and it is equals to PD square plus MD square. So I write it now. So in this right triangle MPD, according to the Pythagoras theorem, MP square equals to PD square plus MD square. MP is the missing side, so we leave it as it is. So it is MP square, and it is equal to PD square. PD is R, therefore PD square is R square plus MD square. MD is 5, therefore MD square is 5 square, that is 25. So in total, according to equation 1, we should find out that MP square equals to R square plus 25. We will repeat on the same process on this in the triangle. That is to say, we join points Q and E together with a straight line. QE is of course the radius of this circle that is equals to R, and because of the fact that the radius QE is drawn to point E, that is the point of tendency of tangent ME with this circle. And remember, your radius is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. So in the next step, we join points M and Q together with a straight line. By joining points M and Q, we can do the right triangle, triangle MQE. So we implement the Pythagoras theorem on this right triangle, triangle MQE. According to the Pythagoras theorem, MQ squared, that is the square of the hypotenuse, is equal to QE squared plus ME squared. Repeat again, according to the Pythagoras theorem, in this right triangle MQE, MQ squared, that is the square of the hypotenuse, equals to QE squared plus ME squared. MQ is the missing sign, so it is CT, so it is MQ squared equals to QE squared. QE is out, therefore QE squared is R squared plus ME squared. ME is 7, therefore ME squared is 7 squared, which is 49. So in total, according to equation 2, we actually found out that MQ squared equals to R squared plus 49. Repeat on the same process on this on this circle. This is to say, we join points S and F together by a straight line. SF is of course the radius of this circle that is equal to R. Again, because of the fact that the radius SF that is equal to R, the radius SF is drawn to point F, that is the point of tendency of tangent MF in this circle, and whenever your radius is drawn to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. So in the next step, we join points M and S together by a straight line. By joining points M and S, we get the right triangle, triangle MSF. So we implement the Pythagoras theorem on this right triangle, triangle MSF. According to the Pythagoras theorem, in this right triangle MSF, MS squared, that is the square of the hypotenuse, is equal to SF squared plus FM squared. Repeat again, according to the Pythagoras theorem, this right triangle MSF, MS squared equals to SF squared plus FM squared. MS is the missing side, so it is CT, so it is MS squared equals to SF square. SF is R, therefore SF square is R square plus FM square. FM is X, therefore FM square is X square. So in total, according to equation 3, we actually found out that MS square equals to R square plus X square. In the next step, we join points P and A together by straight line. Point P is the center of the circle, point A is the point on the circle itself, therefore PA is the radius of the circle that is equal to R. And because of the fact that the radius PA is drawn to point A, that is the point of tendency of tangent ABC with the circle, and whenever your radius is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular, perpendicular to AP, it means that this circle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points Q and B together by straight line. QB is also the radius of this circle that is equal to R. And because of the fact that the radius QB is drawn to point B, that is the point of tendency of tangent ABC with this circle, and whenever your radius is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule 1. And finally, we join points C and S together by straight line. CS is of course the radius of this circle that is equal to R, and according to the fact that the radius SC is drawn to point C, that is the point of tendency of tangent ABC with this circle, and whenever your radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius CS. If ABC is perpendicular to CS, it means that this circle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule 1. So those 3 points P, Q, and S, they are at the same distance from the straight line ABC. Therefore, the 3 points P, Q, and S must be located on one straight line. That is to say, PQS is one straight line, or PQS is a straight line. And exactly for the same reason that those 3 points P, Q, and S are at the same distance from the straight line ABC, therefore the straight line PQS must be parallel to the straight line ABC. And therefore we can implement here rule 17. So I'll repeat quickly rule 17. According to rule 17, the sum of one-sided internal angles that are located between parallel lines is equal to 180 degrees. So in the drawing we have line A that is parallel to line B, the red line C intersects with those 2 lines A and B at those 2 points. In addition, we have those 2 angles alpha and beta. Those 2 angles alpha and beta are defined as one-sided interangles. They are one-sided angles because they are located at the same side of the red line C, that is the left side, and they are also defined as interangles because they are located between the parallel lines A and B. So in total, are defined as one-sided interrogants, and according to this rule 1, the sum of two one-sided interrogants is equal to 180 degrees. That is to say, alpha plus beta is equal to 180 degrees. We can actually implement rule 17 in our drawing. Why? Because in our drawing we have those two angles that are defined as one-sided interrogants, and they are located between the parallel lines PQS and ABC. And therefore, according to rule 17, the sum of those two angles must be equal to 180 degrees. This is a right angle, that is to say it is equal to 90 degrees in size. So 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Those two angles are also defined as one-sided interangles. This angle equals to 90 degrees plus this missing angle, in total the sum of those angles must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. Those two angles are also defined as one-sided interangles. This angle equals to 90 degrees. So 90 degrees plus this missing angle, in total the sum of those angles must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interangles. This angle equals to 90 degrees. So 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So actually, inside quadrilateral QSCB we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be its right angle if not a square. So we relate to this quadrilateral QSCB as a right angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QCCB, side BC must be equal to the opposite side QS. But BC is 3, therefore the opposite side QS must be also equal to 3 units in its length. Likewise, inside this quadrilateral PQBA we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be its right angle if not a square. So we relate to this quadrilateral PQBA as right angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PQBA, side AB must be equal to the opposite side PQ, but AB is 3, therefore the opposite side PQ must be also equal to 3 units in its length. In the next step we'll copy the big triangle PMS, this big triangle PMS in a new page, and we will analyze this big triangle PMS. So actually, this is triangle PMS that occurs from the original drawing. Line segment MQ is defined as the median of this triangle PMS. What is the definition of a median? A median is a line segment that connects the vertex to the midpoint of the opposite side. Again, a median is a line segment that connects, is a line segment in a triangle that connects it is a line segment that connects the vertex to the midpoint of the opposite side. In this triangle NPS, the median MQ connects the vertex M to the midpoint of PS, that is point Q. Why point Q is the midpoint of PS? Because of the fact that PS in total equals to 3 plus 3, that is 6, and at the midpoint point Q, side PS has been bisected into two halves. Each half equals to 3 units. PQ equals to 3 and QS equals to 3. So the median of any triangle bisects the opposite side into two halves. The opposite side in relation to the vertex. PS is the opposite side of the vertex M. And the median MQ bisects PS into two halves. But the question is, what is the length of the median MQ? Actually, we have a special formula that will help us to find out the length of a median in any triangle. So okay, this is triangle ABC. This is side AB, that is equals to 2 units in its length. This is side AC, that is equals to 3 units in its length. And this is side BC, that is equal to 1 unit in its length. The median in this triangle ABC is AD. It connects the vertex A to the midpoint of the opposite side BC. So at point D, the opposite side BC is bisected into two halves. The first half is BD and the second half is DC. But the question is, what is the length of the median AD? The length of the median AD is equal to the square root of 2b squared plus 2c squared minus 8c. Again, the length of the median AD is equal to 2b squared plus 2c squared minus a squared over 2. But again, the length of this median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. So we use this new formula in order to find out the length of this median MQ. According to the new formula, the length of the median MQ will be equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. But again, MQ equals to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. Here we'll multiply this equation 1 by 2, and we get that according to equation 1, 2 times MQ 2 times MQ equals to the square root of 2 times MP squared plus 2 times MS squared minus PS squared. Okay, so repeat again, according to equation 1, we can find out that 2 times MQ equals to the square root of 2 times MP squared plus 2 times MS squared minus PS squared. Here we will square both sides of this equation 1. So what is the square of 2mq? 2mq squared is 4mq squared. Because 2 squared is 4 and mq squared is mq squared. So total 2 times mq is 4 times mq squared. And here we square also this side of this equation 1. And because of the fact that the square cancels the root, we left only with 2 times mp squared plus 2 times ms squared minus ps squared. So according to equation 1, 4 times mq squared equals to 2 times mp squared plus 2 times ms squared minus ps squared. So according to equation 1, 4 times mq squared. According to this equation, equation 2, mq squared equals to r squared plus 49. Therefore, we substitute mq squared here by r squared plus 49. And it is equal to 2 times mp squared. According to equation 1, mp squared equals to r squared plus 25. Therefore, we substitute mp squared here by r squared plus 25 plus 2 times ms squared. Ms squared according to equation 3 equals to r squared plus x squared. Therefore, we substitute ms squared here by r squared plus x squared. And we have also minus ps squared. ps in total equals to 3 plus 3, that is 6. Therefore, ps squared is 6 squared, that is 36. Therefore, minus ps squared is minus 36. Here again, minus ps squared is minus 36. So here we open the brackets on both sides of this equation, equation 1, and we get that 4 times r squared plus 4 times 49 is 196, so it is plus 196, that is equal to 2r squared plus 2 times 25 is 2 times 25 is 50, so it is plus 50 plus 2r squared plus 2x squared minus 36. Here we subtract 4r squared for this equation, equation 1. So here 4r squared will get cancelled, and you left only with 196. So here we have to subtract 4r squared from this side of the equation. We have 2r squared plus 2r squared is 4r squared, so those two expressions will get cancelled. And after we subtract 4r squared from both sides of this equation 1, in this side of the equation we left only 50 minus 36, that is 14, plus 2x squared. So in total, according to equation 1, we actually found out that 196 equals to 14 plus 2x squared. Here we subtract 14 from this equation, equation 1, and we get that 196 minus 14 is 182. So 182 equals to 2x squared. So here we divide this equation 1 by 2, and we get that 182 over 2 is 91, so 91 equals to x squared. We take a root out of this equation, and we get that finally x equals to the square root of 91. The square root of 91 is 9.54 units. And that is the answer to the question. I'll repeat again. We should find out that the length of this nice tangent MF is equal to x. It is equal to either the square root of 91 units, or in terms of numbers, the length of this tangent MF that is equal to x is equal to 9.54 units. So we finish with the first question. The next step, I present you the second question, and we solve the second question of this lecture. So, our mission in this second question is to find out the length of this tangent AB is equal to x. So we have to find out the value of x. So in the drawing we have quarter circle AOB. Inside this quarter circle AOB we have this small circle. This circle touches the big quarter circle at this point. So we define the touching point, this point is point K. And we will define the center of this small circle, this point is point C. In the next step, we will join point C and Q together by a straight line. Point C is the center of this small circle, point Q is the point of the small circle itself, therefore CQ is the radius of this small circle. We define the radius of this small circle as A, so CQ equals to A. And because of the fact that the radius CQ is drawn to point Q, that is the point of tendency of tangent AB with this small circle, and whenever you have radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points P and C together by straight line. Point P is the point of tendency of tangent AP with this small circle. So we join points P and C together by straight line. PC is of course the radius of this circle, that is equal to A according to our definition. And because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle APC. So in the next step, I'll copy the right triangle APC in a new page and we will implement the Pythagoras theorem on this right triangle, triangle APC. Here by PT is a variation for Pythagoras theorem. So actually, this is the right triangle APC, that is according to the original drawing. In this right triangle APC, according to the Pythagoras theorem, AC squared, that is the square of the hypotenuse, AC squared is equal to AP squared plus PC squared. So write it down, this will be equation 1. AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. AC is the missing side, so we leave it as it is, so it is AC squared is equal to AP squared. AP is x, therefore AP squared is x squared plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we should found out that AC squared equals to x squared plus a squared. This is point K, that is the touching point between the big quarter circle and this small circle. So at this point K, the two circle and the quarter circle have an internal launch between them. That is to say, they touch each other internally in this point K. And whenever you have an internal launch between two circles, you can implement here, rule 9. So let's click on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. In the drawing, we have two circles. The center of this big circle is here at point O. The center of this small circle is here at point M. And the straight line that connects their centers together is, of course, the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. Again, the straight line OM, according to this rule 9, the straight line OM must pass through point P, that is their touching point. O and P is one straight line. Again, according to this rule 9, O and P is one straight line. So we can actually implement rule 9 in our drawing. Why? Because we have internal launch between the small circle and the big quarter circle. So according to rule 9, we have here the center of this big quarter circle is at point O. The center of this small circle is at point C. And the straight line that connects the centers together is, of course, the straight line OC. And according to rule 9, the straight line OC must pass through their touching point, that is the point K. Again, the straight line OC must pass through point K, that is their touching point. Or OCK is one straight line. Again, OCK is one straight line according to rule 9. So we join points O and C together with straight line. And the straight line OC must pass through point K, that is their touching point, according to rule 9. So it is very easy to see that the straight line OC indeed passes through point K, that is their touching point, exactly according to rule 9. What is the length of line 7 CK? CK is, of course, the length of this small circle, that is A. CK equals to A. What is the length of this line 7? Line 7 OK. OK is, of course, the radius of the quarter circle, so we define the radius of this quarter circle as B. OK equals to B. OB is also the radius of the quarter circle, therefore it is equal to B. AO is also the radius of the quarter circle, that is equal to B. What is the length of line 7 OC? For the drawing, it is very easy to see that OC in total equals to OK minus CK. Again, OK minus CK equals to OC. So I write it down. OC equals to OK minus CK. So actually, OC in total equals to OK is B minus CK. CK is A, so in total OC equals to B minus A, everything is there. So OC equals to B minus A. So in the next step, I'll copy the right triangle OCQ in the new page and we'll implement the Pythagoras theorem on this right triangle OCQ. Here by PT is the progression from Pythagoras theorem. So actually, this is the right triangle OCQ that I covered from the original drawing. In this right triangle OCQ, according to the Pythagoras theorem, OC squared, that is the square of the hypotenuse, equals to CQ squared plus OQ squared. So write it down. This will be equation 2. OC squared, that is the square of the hypotenuse, is equal to CQ squared plus OQ squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equal to CQ squared. CQ is A, therefore CQ squared is A squared, plus OQ squared. OQ is 5, therefore OQ squared is 5 squared, that is 25. So in total, according to equation 2, we found out that B minus A squared equals to A squared plus 25. So B minus A squared is equal to B squared plus A squared plus 2 times A times B, and it is equal to A squared plus 25. Repeat again, according to equation 2, we found out that B squared plus A squared minus 2 times AB equals to A squared plus 25. So here we have A squared on both sides of this equation, equation 2, so A squared gets cancelled. After we cancel A squared, in the side of the equation, this equation 2 we left only with B squared minus 2 times AB. On the other side of this equation 2, we left only with 25. So in total, according to equation 2, we found out that B squared minus 2 times AB equals to 25. In the next step, we do a construction, that is to say, from this point C, we will draw perpendicular on AO. Again, from point C, we will draw perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point N. So by doing this construction, you can do quadrangle CN or Q. Inside this quadrangle CN or Q, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 pieces, and again total must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this 4 pieces again must be equal to 90 degrees in its size. So inside quadrangle NCQO, we have quadrangles, and according to rule 5, any quadrangle that has 4 rectangles must meet this rectangle in front of the square. So in order to this quadrangle NCQO, it's a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NCQO, side NC must be equal to the opposite side OQ, but OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the sum rule, in the sum rectangle NCQO, side CQ must be equal to the opposite side ON, but CQ is 8, therefore ON must be also equal to a unit in its length. What is the length of this missing isomethylsymmetry AN? From the drawing it is very easy to see that AN in total equals to AO minus NO. So write it down. AN equals to AO minus NO. So AN equals to AO. AO is the radius of the quadratic circle that is B minus NO. NO is A. So in total AN equals to B minus A units in its length. So in the next step, I'll copy the right triangle A and C in the new page and we'll implement the Pythagoras theorem on this right triangle, triangle A and C. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle A and C that is covered from the original drawing. This right triangle A and C, AC squared, that is the square of the hypotenuse, is equal to AN squared plus NC squared. So I'll write it down. This will be equation 3. So AC squared, that is the square of the hypotenuse, is equal to AN squared plus NC squared. Plus NC squared. So in total, according to the Pythagoras theorem in this right triangle NC, we found out that AC squared equals to AN squared plus NC squared. According to equation 1, AC squared equals to X squared plus A squared. Therefore, we substitute AC squared here in this equation 3, by x squared plus a squared, and it is equal to an squared. An is b minus a, therefore an squared is b minus a squared plus nc squared. Nc is 5, therefore nc squared is 5 squared, that is 25. So in total, according to equation 3, we have found out that x squared plus a squared equals to b minus a squared plus 25. So x squared plus a squared equals to b minus a squared is equal to b squared plus a squared plus 2 times a times b. Here plus 25. So here we have a squared both sides of the equation, so a squared will cancel, so we cancel a squared in this of this equation. We will have to with x squared, and the other side of the equation we have b squared plus 2 times ab plus 25. But according to this equation 2, we have only found out that b squared minus 2 times ab is 25. Therefore, we substitute b squared minus 2 times ab here by 25. And we get that x squared equals to, again, b squared minus 2 times ab is 25. And we have plus 25. So in total, x squared equals to 25 plus 25, that is 50. So x squared equals to 50. We take out of this equation and get that x equals to the square root of 50. 50 is 25 times 2. And the square root of 25 is 5. Again, the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So the answer to the question is that the length of this tangent AEP, that is equal to x, it is equal to either 5 times square root of 2 units, or in terms of numbers, the length of this tangent AEP that is equal to x is equal to 7.071 units in itself. Okay, so in the next step, I'll summarize the lecture. We start with the first question, of course. Our mission in this first question is to find out the length of this tangent MF that is equals to x. We have to find out the value of x. So, in the drawing, we have 3 identical circles. We have also the big tangent ABC that is tangent to this circle at this point A, it is tangent to this middle circle at this point B, and it is also tangent to this circle at this point C. In addition, you know that this is line segment AB that is equal to 4 units in its length, and line segment BC is also equal to 4 units in its length. In addition, we have this is the convex point M. For this convex point M, we have tangent MD that is tangent to the circle at point D, and the length of this tangent MD is 5. In addition, we have also tangent ME that is tangent to this middle circle at this point D, and the length of this tangent MD is 7. And finally, we also have tangent MF that is tangent to this circle at point F, and the length of tangent MF is x. So mission is to find out the length of tangent MF that is equal to x. Our mission is to find out the value of x. So first of all, we defined the center of this circle, this point is point P. We define the center of this middle circle, this point is point Q, and finally we define the center of this circle, this point is point S. In the next step, we join points P and D together by a straight line. PD is the radius of this circle. We define the radius of this circle is R, and because of the fact that those three circles are identical, those two circles must also have the same radii, that is R. Okay? And because of the fact that the radius PD that is equal to R, the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle, and whenever your radius is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees in its size. In the next step, we join points M and P together by a straight line. By joining points M and P, we create the right triangle PD. So, here we implemented the Pythagoras theorem with this right triangle PD. According to the Pythagoras theorem, in this right triangle PD, NP squared, that is the square of the produce, is equal to PD squared plus MD squared. And again, according to the Pythagoras theorem, this right triangle PD, MP squared equals to PD squared plus MD squared. MP is the missing side, so it is MP squared equals to PD squared. PD is R, therefore PD squared is R squared plus MD squared. MD is 5, therefore MD squared is 5 squared, that is 25. So according to equation 1, we found out that MP squared equals to R squared plus 25. Repeated on the same process on this middle circle, that is to say we join points Q and E together by a straight line. QE is of course the radius of this circle that is equal to R, and because of the fact that the radius QE is drawn to point E, that is the point of tendency of tangent ME with this middle circle, and whenever your radius is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees. In the next step, we join points Q and M together by a straight line. By joining points Q and M, we get a right triangle MQE. Then we implemented the Pythagoras theorem on this right triangle MQE. According to the Pythagoras theorem on this right triangle MQE, MQ squared equals to QE squared, MQ squared equals to QE squared plus EM squared. Okay, again, according to the Pythagoras theorem, MQ squared equals to QE squared plus ME squared. MQ is the missing side, so it is MQ squared equals to QE squared. QE is R, therefore QE squared is R squared plus EM squared. EM is 7, therefore EM squared is 7 squared, that is 49. So in total, according to equation 2, we shall find out that MQ squared equals to R squared plus 49. We put it on the same process on this circle. That is to say, we join points S and F together by a straight line. SF is the radius of this circle that is equal to R. And again, according to all 1, this angle equals to 90 degrees. In the next step, we join points S and M together by a straight line. By joining points S and M, we get a right triangle SFM. Okay. So, according to the Pythagoras theorem, in this right triangle MSF, MS squared equals to SF squared plus MF squared. Okay, again, according to the Pythagoras theorem, this right triangle MSF, MS squared equals to SF squared plus FM squared. SM is the missing side, so it is, and it is equal to SF squared. SF is R, therefore SF squared is R squared plus MS squared. MS is X, therefore 3, mf is x, therefore mf squared is x squared. So in total, according to equation 3, we found out that ms squared equals to r squared plus x squared. In the next step, we join points P and A together by straight line. PA is the radius of the circle that is equal to 1. And because of the fact that the radius PA is 1 to point 8, that is the point of tendency of tangent ABC with this circle, and another radius that is 1 to the point of tendency, then tangent ABC will be perpendicular to the radius AEP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. We join points Q and B together by straight line. QB is the radius of this circle that is equal to 1, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points S and C together by straight line. S is the radius of the circle that is R, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Those 3 points P, Q, and S, they are all at the same distance from the straight line ABC, and therefore those 3 points P, Q, and S must be located on one straight line. Again, PQS is one straight line. That is to say, PQS is a straight line, and exactly for the same reason that those 3 points P, Q, and S are located in the same distance from the straight line ABC. Therefore, the straight line PQS must be parallel to the straight line ABC. And because of the fact that PQS is parallel to ABC, we can implement here rule 17. So, I pick rule 17. According to rule 17, the sum of one-sided interangles between two parallel lines is equal to 180 degrees. So in the domain we have line A that is parallel to line B, and we have also this the red line C that intersects with those two lines A and B, those 2 points, and we also have those 2 angles alpha and beta. Those 2 angles alpha and beta are defined as one-sided interangles, and according to this rule 17, the sum of one-sided interangles is equal to 180 degrees. So that is to say, alpha plus beta equals to 180 degrees. So if we implement rule 17 in our domain, in our domain we have those 2 angles that are defined as one-sided interangles, and they are located between the parallel lines PQS and ABC. Therefore, according to rule 17, the sum of those 2 one-sided interangles is equal to 180 degrees. But this angle equals to 90 degrees, so 90 degrees plus the side of this missing angle, in total the sum of those angles must be equal to 180 degrees, therefore this missing angle must be equal to 90 degrees in size. Likewise, those 2 angles are also defined as one-sided interangles, and according to rule 17, the sum of those angles is equal to 180 degrees. So 90 degrees plus the size of this missing angle in total must be equal to 180 degrees, therefore this missing angle must be equal to 90 degrees in size. And finally, we also those 2 angles that are defined as one-sided interangles, and they are located between those 2 parallel lines. Therefore, according to rule 17, the sum of those 2 angles must be equal to 180 degrees. So, but this angle is the right angle according to rule 1. So 90 degrees plus the size of the size of this angle, in total the sum of those angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in size. And finally, those 2 angles are also defined as one-sided interangles, and the sum of those 2 angles must be equal to 180 degrees according to rule 17. But this is the right angle, it is equal to 90 degrees in size. So 90 degrees plus the size of this missing angle, in total the sum of those angles must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in size. So inside this quadrangle QSCB we have 4 angles, and according to rule 5, any quadrangle that has 4 angles must be its right angle if not a square. So relate to this quadrangle QSCB is right angle because it has 4 right angles. But we also know that the opposite sides of the right angle are equal to each other. So left angle QSCB side BC must be equal to the opposite side QS. But BC is 3, therefore QS must be also equal to 3 in its length. Inside this quadrant PQBA we have quadrants, and according to our 5, any quadrant that has 4 rectangles must be a rectangle in front of square. So we relate to this quadrant PQBA is rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle PQBA, side AB must be equal to the opposite side PQ, but AB is 3, therefore PQ must be also equal to 3 units in its length. The next step, I copied the big triangle MPS in a new page and analyze this big triangle MPS. So actually, this is the big triangle MPS that I copied from the original drawing. This is line 7 MQ. Line 7 MQ is defined as the median of this triangle MPS. So what is the median? A median in a triangle is a line segment that connects the vertex to the midpoint of the opposite side. Again, a median of a triangle is a line segment that connects the vertex to the midpoint of the opposite side. The median MQ connects the vertex M to point Q, and point Q is the midpoint of PS. Why point Q is the midpoint of PS? Because of the fact that PS in total equals to 3 plus 3, that is 6. And at point Q, PS has been bisected into 2 halves. The first half is PQ, that is 3, and the second half is QS, that is also 3. So the median of a triangle starts from the vertex and it bisects the opposite side of the vertex. The median MQ bisects side PS into 2 halves. But the question is, what is the length of the median MQ? Actually, we have a special formula for the length of a median of any triangle. Actually, according to the special formula, the length of we have here triangle ABC. In this triangle ABC, side AB equals to B units in its length, side AC equals to C units in its length, and side BC equals to A units in its length. AD is the median of this triangle ABC. It starts from the vertex A and ends at point D, that is the midpoint of the opposite side BC. At point D, BC has been bisected into 2 halves. Each half equals to BC over 2. BD equals to DC equals to BC over 2. But the question is, what is the length of the median AD? The length of the median AD is equals to square root of 2 times B square plus 2 times C square minus A square over 2. Again, AD equals to 2 times B square plus 2 times C square minus A square over 2. According to the new formula, the length of the median MQ will be equal to the square root of 2 times MP square plus 2 times MS square minus PS square divided by 2. This equation is the implementation of the new formula in this triangle MPS. Here we multiply this equation 1 by 2, and finally found out that according to equation 1, 2 times MQ equals to the square root of 2 times MP square plus 2 times MS square minus PS square. Here we squared both sides of this equation 1. 2 times MQ squared is 4MQ squared, and we squared also this side. The square cancels the root, and we left only with 2 times MP square plus 2 times MS square minus PS square. So according to equation 1, 4 times MQ square equals to 2MP square plus 2MS square minus PS square. We have here 4 times MQ square. Okay, but here MQ square equals to R square plus 49. Therefore, we substitute MQ square here by R square plus 49, and we have also 2 times MP square. But according to equation 1, MP square equals to R square plus 25. Therefore, we substitute MP square here by R square plus 25, and we have also 2 times MS square. But MS square, according to this equation 3, equals to R square plus X square. Therefore, we substitute ms square here by r square plus x square, and we have also minus ps square. PS in total equals to 3 plus 3, that is 6. Therefore, PS square is 6 squared, that is 36. So minus PS square is minus 36. So we substitute minus PS square here by minus 36. Here we open the brackets on both sides of this equation, equation 1, and finally found out that 4 times r square, and we have 4 times 49, that is 196, is equal to 2 times r square, plus 2 times 25, that is 50, and we have 2r square plus 2x square minus 36. Here we subtracted 4r square for this equation, equation 1, so 4r square here will get cancelled, and in this side of equation 1 we left only 196. On the other side of this equation, equation 1, we have 2r square plus 2r square, that is 4r square, so those two expressions will get cancelled because we subtracted 4r square also from this side of the equation. After we subtracted 4r square, here we left only with 50 minus 36, that is 14, plus 2x squared. So in total, according to equation 1, we should find out that 196 equals to 14 plus 2x squared. Here we subtracted 14 from this equation, equation 1, we can find out that 196 minus 14 is 182. So 182 equals to 2x squared. Here we divided this equation 1 by 2, and finally found out that 192 over 2 is 91, so 91 equals to x squared. Here we took out of this equation, and finally found out that x equals to either the square root of 91 units, so in terms of numbers, x equals to 9.54 units. So I repeat again, we found out that the length of this 9/7 mf, that is equal to x, it is equal to either the square root of 91 units, or in terms of numbers, the length of this standard mf that is equal to x is equal to 9.54 units. So we finish with the first question. In the next step, I presented to you the second question, and we solve the second question of this lecture. So actually, in the second question, in this second question, our mission is to find out the length of this standard AEP that is equal to x. So we have to find out the value of x. So in the problem we have quarter circle AOB, and inside this quarter circle AOB we have this small circle, and tangent OB is tangent to this small circle at this point Q, and this small circle touch the quarter circle at this point K. In addition, we know that this is line segment OQ that is equal to 5 units in its length, and our mission is to find out the length of this tangent AP that is equal to x. So we have to find out the value of x. So first of all, we define the center of this small circle. This point is point C, and we join point C and Q together by certain C. Q is of course the radius of this small circle. We define the radius of this small circle CQ as A, and because of the fact that the radius CQ that is equal to A, the radius CQ is drawn to point Q, that is the point of tendency of tangent OB with this small circle. Whenever you have radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points C and P together by straight line. Point P is the point of tendency of tangent AP with this small circle. So CP is of course the radius of this small circle that is equals to A, because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this circle, and whenever your radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points A and C together by a straight line. By joining points A and C, we create the right triangle ACP. So copy this right triangle ACP in a new page and we implemented the Pythagoras theorem on this right triangle APC. So actually, this is the right triangle APC that I copied from the original drawing. In this right triangle APC, AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. AC is the missing side, so we leave the CT, so it is AC squared equals to AP squared. AP is x, therefore AP squared is x squared, plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we can formula that AC squared equals to x squared plus a squared. So here we have in this point K, we have an internal notch between this small circle and this big quarter circle. That is to say, they touch each other internally at this point K. And whenever we have an internal notch between two circles, you can implement rule 9. So let me click on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects the centers together passes through their touching point. So in the drawing we have two circles. The center of this big circle is at point O. The center of this small circle is at point M. And the straight line that connects the centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. Again, the straight line OM must pass through point P, that is the touching point. O and P is one straight line. Again, according to this rule 9, O and P is one straight line. So we can actually implement rule 9 in our drawing. Why? Because in our drawing we have internal notch between this small circle and this big quarter circle, this point K. Therefore we can implement here rule 9. The center of this big quarter circle is at point O. The center of this small circle is at point C. And the straight line that connects their centers together is of course the straight line OC. And according to rule 9, the straight line OC must pass through their touching point, that is point K. Again, the straight line OC must pass through point K, that is their touching point. Or OCK is one straight line. Again, according to rule 9, OCK is one straight line. So we actually join points O and C together by straight line. And the straight line OC indeed passes through point K, that is their touching point, exactly according to rule 9. But what is the length of CK? CK is the radius of this small circle, that is A. What is the length of line segment OK? OK is the radius of the big quarter circle, that is equal to B according to our definition. So in total, CK equals to A and OK equals to B. What is the length of line segment OC? OC equals to OK minus CK. Again, OC equals to OK minus CK. Again, OC equals to OK minus CK. So OC equals to OK, that is B, minus CK, that is A. So in total, OC equals to B minus A units in its length. In the next step, we copy the right triangle OCQ in a page and implement the Pythagoras theorem on this right triangle OCQ. So actually, this is the right triangle OCQ that I copied from the original drawing. In this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. OC is V minus A, therefore OC squared is V minus A squared, and it is equals to CQ squared. CQ is A, therefore CQ squared is A squared, plus QO squared. QO is 5, therefore QO squared is 5. QO squared is 5 squared, that is 25. So in total, according to equation 2, we shall find out that B minus A squared equals to A squared plus 25. In the next step, we did the construction. That is to say, from this point C, we draw perpendicular on AO. Again, from point C, we draw perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point N. By doing this construction, if you did it, quadrangle NCQO. Inside this quadrangle NCQO, we have 1, 2 3 The sum of 3 is 270 degrees. So 270 degrees plus the size of this 4 facing angle, total must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees in its size. So inside quadrangle NCQO, we have 4 angles, and according to rule 5, any quadrangle that has 4 angles must be this rectangle plus the square. So we relate to this quadrangle NCQO as a rectangle because it has 4 angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NCQO, side OQ must be equal to the opposite side NC. But OQ is 5, therefore the opposite side NC must be also equal to 5 units in its length. Likewise, according to the same rule, in the same rectangle NCQO, side CQ must be equal to the opposite side NO, but CQ is A, therefore NO must be also equal to A units in its length. What is the length of the recent line segment AN? AN equals to AO minus NO. Again, AN equals to AO minus AO. So AN in total equals to AO that is B minus NO that is A. So in total AN equals to B minus A units in its length. In the next step, we'll go with the right triangle ANC in Euclid and implement the Pythagoras on this right triangle ANC. So this is the right triangle ANC that is according to the original drawing. This right triangle ANC, AC squared, that is the square of the hypotenuse, is equal to AN squared plus NC squared. AC squared, according to equation 1, is equal to X squared plus A squared. Therefore, we substitute AC squared here by X squared plus A squared, and it is equal to AN squared. AN is B minus A, therefore AN squared is B minus A squared, plus NC squared. NC is 5, therefore NC squared is 5 squared, that is 25. So in total, according to equation 3, we found out that X squared plus A squared equals to B minus A squared plus 25. So X squared plus A squared equals to B minus A squared. B minus A squared equals to B squared plus A squared minus 2 times AB plus 25. Here we have A squared on both sides of the equation, so A squared will cancel. After we cancel A squared, this side of the equation 3, we left only with X squared. The other side of this equation 3, we left with B squared minus 2 times AB plus 25. So in total, according to equation 3, we should find out that X squared equals to B squared minus 2AB plus 25. But according to equation 2, this equation 2, B squared minus 2AB equals to 25. Therefore, we substitute B squared minus 2AB here by 25, and actually found out that in total equals to X squared, according to equation 3, X squared equals to B squared minus 2AB, that is 25, plus 25. So in total, X squared equals to 25 plus 25, that is 50. So X squared equals to 50. We took out of this equation, and found out that X equals to the square root of 50. 50 is 25 times 2. The square root of 25 is 5. Therefore, in total, this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So in total, we found out that the length of this standard AP, it is equal to either 5 times square root of 2 units, or in terms of numbers, the length of standard AP that is equal to X is equal to 7.071 units in its length. Okay, thank you very much.